A few other new ideas is something called predict proba. Very, very important. This again was not there for regression. This is only for classification. Okay. What are the different steps for model building? First, we take the data, we build a model, we train a model on the training data, and then we do predictions on the testing data. Until here, we are sorted. Even in regression, we were able to do this. We were able to get the predicted values on the testing data. Additionally, in classification, what you can do, you can also get the predicted class probabilities, because that is what classification is inherently doing behind the scenes, right? So here also what we have done, if you see, we have already trained a machine learning model on the training data. We have done dt.fit on x train, y train. So that dt.fit we have done. We have already trained the decision tree model on the training data. And now we want to use that decision tree model on the testing data and find out the class probability. So what is going on behind the scenes here is, if I just annotate this a little better for you, this is the 0 class and this is the 1 class. And if you see what's going on here, we already have trained the classification model. This is the logistic model. So we are looking at the first row of my X test. So based on, and see, this is the testing data. So the Y is missing. We only have the X here, right? So we have to predict the Y. So given this new observation, we are trying to do the prediction. So based on this new observation, imagine this is like your decision boundary. We talked about that, right? So this is like the class 0, this is like the class 1. This is the 0 side, this is the 1 side. So given a new data point, you are trying to predict what is the probability it is on this side and what is the probability it is on this side. That is all you're trying to do. You're trying to find out the probability, how close it is to the 0 side and how close it is to the 1 side. That is the intuition of what we are trying to do here. So, and that's how we get these class probability values. So given a new person, given a new patient, we have a 45% probability this person is diabetic. And obviously 100 minus that is 54.74% probability is not diabetic. So we in addition to just getting the labels, we are also getting the actual class probabilities. Okay, so you can see the fourth person. The fourth person is this one. This person apparently has a very low plasma value, right? 61 glucose level is very low. So this is like extremely low. This the glucose, I think sometimes even very low sugar is bad, right? So this is very low glucose level, and because the glucose level is so low for this fourth person, you see for the fourth person there is only a 3.98% probability of diabetes. Okay, you can see how beautifully the data is correlating. So we are looking at the features of a new observation, and we are able to find out the probability the person is diabetic and the probability the person is not diabetic. And what we can now do, is we can use these probability values and we can write our own custom prediction. We can build the model, we can get the predict proba values, and now we can write our custom if else statement. We can say, hey, if the probability of diabetes is more than, we can use a parenthesis. So if it is more than 0.2, so if anybody's diabetic probability is more than 0.2, then classify that person to be diabetic, then diabetic. Okay, so let me, so then diabetes, else not diabetes. See what I'm getting at? I've reduced the thresholds. I have reduced the thresholds because remember, diabetes is a deadly disease. It is a deadly disease. So even if there is a slightest of chance, even if there is a slightest of possibility that a person might have the disease, I will still warn the person. I don't want to take any risk. Even if there's a slightest of possibility a person might have diabetes, I will warn the person that, hey, you might be diabetic. Even if you have a 20% probability of diabetes, I will still classify diabetes, else I will not. So you can write your own custom if-else statements based on the probability values, right? So how does it really happen in Scikit-learn behind the scenes? Because obviously our focus is Scikit-learn and we are using that library. In Scikit-learn, there is a default predict function. There is a default predict function. This will work based on the 50% threshold. Okay, so you can write your own custom thresholds, which is what we do in practice. If you're trying to solve real business cases, you will write your own custom if conditional statements for the prediction. But in Scikit-learn, if you're using scikit-learn.predict, what will it do behind the scenes? Behind the scenes, it will use the 50% threshold. So it is going to compare with the 50% threshold. If the probability is more than 50, it is diabetic. Else, if it is less than 50, it is not diabetic. This is what it will do behind the scenes.